Welcome to the Deeks.ai podcast, where Wake Forest innovators unpack the real-world magic of artificial intelligence through candid conversations. I'm Michael Ferrari.
I'm Ryan Scholl.
Please join us as we explore how artificial intelligence is transforming work across campus, one fascinating story at a time.
Forget the tuxedos and the martinis. Sarra Alqahtani is training a different class of super agent. In this episode, we go inside the lab to see how multi-agent reinforcement learning is being used to protect the planet. We move past the hype of chatbots to look at AI that actually does things, navigating complex environments, making split-second decisions, and solving problems without a human holding the remote. From tracking illegal gold mining in the Amazon to securing your self-driving car, Dr. Alqahtani explains why the future of global security isn't a man in a suit. It's a swarm of agents. Join us for a masterclass in how reinforcement learning is moving from the whiteboard to the wild.
We are back with another Deeks.ai episode. This is the #1 higher education artificial intelligence podcast at Wake Forest University. So thank you again to all our listeners. And I think we have to mention again our big announcement of AI Fest that's coming up December 15th and 16th. You can find all the information on our website, which Michael is really good at telling us what that website is.
Yep. So you can go to is.wfu.edu and it's right on the home page, or you can go to go.wfu.edu/AI Fest.
Fantastic. So if you're listening to this before AI Fest, then come join us on the 15th and 16th and come talk to Michael and I in person. If you're listening to this afterwards, go to the website and watch all the recordings. Should be a fun little event. And with that, we're going to welcome our guest today. She is an associate professor in the Department of Computer Science here at Wake Forest and self-taught on artificial intelligence. She works on the security of reinforcement learning. Thank goodness, we all need security around artificial intelligence. And recently, if my research is correct, has been awarded not one but 2 large grants for her work. So I want to welcome Sarra Alqahtani. And if you wouldn't mind, can you tell us a little bit about yourself?
Yeah, I am associate professor at the computer science department. I got my PhD from University of Tulsa in cloud security, and as you mentioned, I taught myself during my postdoc studies AI, specifically reinforcement learning, and that's what I do now. I study security and explainability of reinforcement learning and multi-agent reinforcement learning.
Good, because we really need somebody to explain all of this to us. So we're looking forward to that. One of the things I know we want to talk about, probably our main topic, is going to be agents. Now, I know my children are going to be very disappointed that we're not talking about Men in Black or 007. 2025 was supposed to be the year of agent. Yeah, well, that didn't really happen. So can you explain to us what an agent is?
Think about when you teach a kid how to ride a bike. That's an agent. It's a piece of software that we train it to do the task we want it to do without explicitly telling it how to do it, because it's hard to explain every single thing about the task in real world. So for example, if we want the agent to fly a drone, it's infinite. There are infinite parameters to consider to teach the agent how to fly the drone. But we could tell the agent, here's the task, go try to fly the drone. If you fail, we're going to give you negative reward or punishment. And if you succeed, we're going to keep giving you positive rewards. So that teaches the agent how to accomplish the task, just like humans.
So we're not talking about these agents that ChatGPT keeps telling us about that go out and do your grocery shopping, or agents that look up a couple things online like deep research. What you're talking about is agents that are really productive out in the real world. And you started explaining reinforcement learning, I believe, with the reward system. So can you give us a little bit of background about reinforcement learning?
Yes. So, you mentioned ChatGPT or generative AI. It's you could use reinforcement learning to train these tools or these agents. So reinforcement learning is used inside ChatGPT or DeepSeek, and that's actually what makes DeepSeek shines two years ago, because they did a tweak for the reinforcement learning algorithm behind training DeepSeek. So reinforcement learning, it's a mathematical model. You explain it's a piece of, as I said, piece of code or software that has something we call states, meaning the world states. Okay, so the agent's gonna be it's gonna act in the world. So the world has states. For example, self-driving car, the states could be now this is a stop sign. Next, this is a just speed, certain speed highway, right? So these are the states of the world. And then there are actions. The agent is allowed to take certain actions, right? And then there's a reward based on your action. The state of them, if your world will change, and based on that, we're going to give you a reward. I hope that's not too mathematical or too complicated.
How do you reward an algorithm? Like, what do you give it more electricity?
No, you give it positive and negative numbers. It's like math.
Ah,
Yeah. So accumulate and increase the positive value you get.
so the goal of the AI system is to achieve the highest amount of something, and you reward it with plus one, plus two when they do it when it does the proper outcome, correct?
Yeah, let me go back to the example of self-driving car, right? So I will train an agent to drive me from my home to campus, right?
Hmm.
So the reward in this case will be the distance from the destination, which is campus, right? So if the car moves further from campus, it will get punishment, like negative number. And if keeps moving towards campus, it will increase the reward. So that motivates the agent to know, oh, I'm doing good, so I should prioritize or I should move closer to campus, not away from it.
That's interesting. I've always been curious about how that reward function works. I mean, I reward my kids with a piece of candy or a cookie or something, but you can't really, shove a cookie into to a disk drive anymore. So interesting. Okay, so that's sort of the layman's version of how you train these agents, but you actually work with multi-agents, so more than one. Explain how the interaction between those agents.
Right. So you would have multiple agents. Again, when we talk about agents, not necessarily robots, just like different software working together, right? So the reward in this case, there are different ways of reward these agents, but part of the reward would be, yes, accomplish your task, but collaborate with other agents, right? So, for example, a swarm of drones flying to cover an area, right? To monitor an area. So the reward will be cover the area. And we're going to give all of you as a team a reward based on how much you cover of that area. Okay, so the agents will learn and will figure out a plan to distribute themselves in the area to cover the whole area in order to get higher reward.
And so the concept of all these drones working together and training them, this is called multi-agent reinforcement learning. Right.
Yes.
And so this is the basis of your research and how to make that safe and secure.
Right. So I work on single agent and multi-agent as well.
And apparently your work is so fascinating that you've received multiple grants from pretty reputable sources. Is that correct?
Yes, from National Science Foundation.
Fantastic. Fantastic. Well, if that's the only brag you want to give about it, then great. But I think it's pretty impressive.
Thank you.
Um, okay, so tell us a little more about the applications of this of the do you pronounce it MARL or do you call it Marl?
Uh, I call it moral.
Okay. Tell us about some of the applications of that.
All right, so I will give you an application that my research that I focus on in my research is using a swarm or a team of drones to navigate a Amazonian rainforest in Peru to detect illegal gold mining activities. So you think about it, drones flying together in unsafe and wild areas to cover that areas and follow indications of or indicators of gold mining activities to take pictures and fly back to the station. So right now, how they do it, they just fly the drones to go cover the whole area, regardless if there are really any signs of gold mining activities or not. So my research focuses on no, let's do this more efficiently. So we don't want to waste the power in these drones. We want them to just explore the areas that have signs of gold mining activities. Uh, but also, since it's a wild and safe region for drones, we don't want to destroy our drones. We don't want to waste our drones. So we want them to fly and have a plan to keep themselves safe and secure from traffickers or from miners. So that's one application that I focus on. But there are a lot of applications for multi-agent or for Marl. The thing about Marl,
So
it's still in.
let's stick with that example for a second, though. I think if I'm understanding part of what we talked about another time is there are different agents there that have different jobs per se, where one may scout the area at a high level, and then it communicates with others
Mhm.
to go in and do a more specified job function, and then maybe another one does something else. So each agent would have a specialty based on potentially power or cost or
Yes.
specialized camera. So it's not a super behemoth one drone that's doing one thing, but they all have their specialized jobs. Is that
Yes,
a
that's correct. So they are heterogeneous based on their skills, their sensors, their functionalities, and we want to train them to do their tasks very well, and then they collaborate based on these skills. So a drone will one drone or a group of drones could fly higher to just
Mhm.
cover larger areas, and by detecting, well, probably this area has some gold mining activities, and then another group, another team of drones will fly down to take uh, pictures with higher resolutions.
And so there's a system that allows all of these drones to communicate together to work on the collaboration between them all.
Yes, yes,
Okay. Okay, so give us another example. I think you were started to
yes.
say something, and I cut you off. I'm sorry.
Yeah, no, that's fine. A new application, and I'm going to give you applications based on the research I'm doing with my collaborators. So
Yes, please.
yeah, I'm collaborating with researchers from University of Tulsa, Indiana University, to um, to use Marl for disaster response. So think about it: if there's a wildfire, um, hurricanes, something really dangerous, we don't want to send humans there. We don't want to risk their lives, right? So our plan is to develop algorithms to send drones, robots, heterogeneous, actually autonomous robots with like flying robots or ground robots. We want to send them there and without prior training. So the thing with AI algorithms, you have to train them for like days and days, right? But if there's a disaster happening, there's no time to really train them. Okay, so we want to take advantage of the available agents or available algorithms there out there, robots from Germany, from Mexico, from anywhere, and then we put them together on the fly and let them collaborate. Okay, this is ambitious, but with using generative AI like ChatGPT, where we call them LLMs, we think there's a potential, so we let them there to do the work, but then also we have a communication layer between them and humans, okay? And that layer will be, I feel like I'm revealing our own research, but it's like let's take advantage of ChatGPT to translate the communication between robots and humans, right? So that's, I feel, is very ambitious, but very promising direction for using Marl to let them communicate with humans, and then that's my focus is if we want humans to use these technologies, we want them to trust and be able to communicate, and we want these technologies to explain themselves to the humans, right? So yeah, so that's one of the applications that we are also moving towards.
How
So
easy
then,
is it to add or remove to the group?
I'm sorry, can you ask again?
Like how I'm just curious how easy it is to just like add or remove to the group. So for instance, the drones, if you wanted to add another drone or one was damaged and you wanted to take it out.
Um, you could add and remove, that's not hard, but the thing is how you gonna let them collaborate, the collaboration part that so far involves a lot of training. And when I say a lot, it's a lot, like days and weeks and months, right? So the challenge is how to add new drones on the fly, right? So that's our research direction that we are investigating right now.
Okay, so say just for sake of argument, you had 5 drones and you wanted to be like, hey, what would this be like with 10? It's not as easy as just having, buying 5 more and adding them to it.
They could do their task, but they will do their task in isolation. There will be
Gotcha.
that collaboration. They could communicate, but so the thing about AI algorithms, they are fixed when it comes to deployment. When you put an AI out there, it's not going to be adaptive,
Sure.
really. All right. So it depends on the training. Okay. So if
Gotcha.
you give it real data, it's not going to learn from that real data really on real time. Does that make sense?
Yeah. Gotcha.
so you spend a lot of your time studying the safety of this. It
Mm.
seems safe to me. What's the problem?
Okay. You're asking a big question here. Oh, so okay. Um, have you ever used ChatGPT and it gave you weird, stupid, silly answers?
No, it always gives me exactly what I'm looking for every single time.
Yeah, so the thing about AI is it's black box. We don't necessarily know everything about the algorithm or how the algorithm behaves or why. Actually, the main question is why. Because if you understand why the algorithm is doing what it's doing, then you can predict what's going to happen, right? So we have this phenomena in AI in general, not only reinforcement learning, distributional shift, which means when you train the algorithm on certain data set, okay, it will use the distribution underneath this data, okay? So it will like for example, you train a car to drive in the US, okay, with the traffic
Hmm.
laws and everything, it will do great. But the moment you move this car to England, you have to retrain it, right?
Yes.
Because if you let it just drive in England, it might just do crazy stuff, right? So that's the thing about safety, like how when we move the algorithm into a new unseen situation, how could we make sure that the algorithm will still behave safely? Not perfectly. I mean, of course, we want it to behave perfectly, but if not, then can we have some safeguards to protect the system itself and humans around it? So that's the safety part of it. But the other part of it also, so this is inherently part of the algorithms we do, the AI algorithms, but there is an external security factor when it comes to humans trying to attack the system. Okay, I think this example is popular, at least for people who are interested in AI. Um, there was in 2012, there was a research paper about for self-driving cars. If there's a stop sign and that stop sign has just a small, and they put in the stop sign a small black sticker, the classifier, what do we mean by classifier? A system that will take an image and tells you what is in the image. Okay, this is a cat, this is a dog, this is a car. So the classifier misclassified stop sign to a speed sign just because of that small black sticker. So that's something that externally from the algorithm that could happen. Like if you just change something small, tweak something, the algorithm might make a mistake. So how could we protect the algorithm from making such mistakes?
Yeah, that
I can
reminds
imagine.
me of I think it might have been Elon Musk speaking with someone and talking about self-driving and the Teslas, and the person asked them like, so I could just wear a shirt with a stop sign on it and that would read it as a stop sign. And if I'm remembering correctly, he was like, yeah, probably. So yeah, it's
Yeah.
interesting.
I can imagine there might be issues with the hive mind concept, and we have all these machines and different devices now talking to each other, that you could have malicious actors injecting some, some bad code or some virus or something there. Is that a concern with these multi-agent systems?
Yeah, yeah. That's my latest grant is to address such concerns, such problems. So in multi-agent systems or multi-agent model, the attack service, I'm going to use here a term, is bigger because you think about agents as like drones, 5 or 10 drones, and each one of them has a set of sensors, right? So then malicious actors could attack any of these sensors, and just by attacking one agent, and that's what we proved in our first grant, is attacking one agent would hurt the whole system, right? And my latest grant is addressing, okay, so we know that that a serious attack and it could happen. So how could we defend against these attacks? So how could we make sure if one agent is misbehaving or one agent is compromised, either because of sensor failure or if malicious actors, external actors, then how could we isolate that agent? And it is not an easy problem to, especially when it comes to AI, because again, back to the point that we don't usually predict, or we can't predict how these AI system is going to behave in different situations. So if a group of agents working together and one of them is behaving weirdly, so how could we define weird and how could we isolate that agent so it doesn't hurt the rest of the agents?
That sounds incredibly complex.
Let's ask my students.
So many people, even though we're learning more about artificial intelligence, they will conflate artificial intelligence in general and generative artificial intelligence. And a lot of people still think artificial intelligence is whatever you're using on the web with ChatGPT.
Mhm.
But your work, from what I understand, is not so much generative artificial intelligence, but it's the higher level of artificial intelligence, and you're not using these consumer models that everybody plays with out there to write recipes for what's in their pantry. What kind of models are you using to work with?
Right. So you said higher level. I would say it's pretty low level. Oh yeah,
Okay.
it depends how you define high and low in this case.
Hmm.
For me, low level here means like it's the internal algorithms behind these generative AI. So let me connect them together. I will do my best here. So sometimes, or at least it used to, ChatGPT, when you ask questions and gives you response, it will ask you to rate its response, right?
Hmm.
So that's the reward, because there's an agent, or there's a RL, reinforcement learning algorithm, that helps train these models, right? So collect everything written by humans, and then we train them. And then when the agent responds to ChatGPT responds to your question, and you said, "Oh, that's a bad response. That's a punishment," as in for
Mhm.
reinforcement learning, to encourage it to improve its response. So reinforcement learning is, and it's the core component for these generative models. But also there now in the research community in RL, it's pretty common to use these models, ChatGPT and LLMs in general, to help bootstrap the training for reinforcement learning agents. So for example, if I'm training an agent to go to the kitchen and make me a cup of coffee, instead of just this agent will learn from scratch what is coffee, what is a mug, what is all of these things, the LLM model could help the agent to say, like, this is a mug, this is coffee, this is how much you should put together, right? So it's just a bootstrapping thing. Um, so what do I use? I focus on, my work is all research. Hopefully in 2-3 years we will move it to real drones and Amazon. But what we use benchmarks, open source, GitHub code to train our
Mhm.
algorithms, and also to build our own tasks and environments. And so one of my students recently, 3 months ago, he trained an agent for insulin dosing. So the agent will be like your own doctor. You could just, they will give you the dose every time, decide how much. And it's incredibly hard. It's incredibly risky. So the safety part we put there is a limit. I forget the numbers. A limit that you shouldn't you shouldn't give the patients anything beyond this amount, right? So we train the agent to do that.
So that you're talking about an agent, and that seems like you're using something with generative AI, but as we've talked about, generative AI is not deterministic. So for something like medical dosing, why wouldn't you use something that's completely deterministic and you understand what it's doing at the same time?
That's a great question.
Yeah, like where does the generative AI help? Like where does that take it to the next level?
Uh, we did not actually use generative AI for that. We used just reinforcement
Okay.
learning, just an
Okay.
agent. So, because that was like for a research paper, so it was for the safe, how to keep the agents, or how to keep the patient safe, right? So the agent will,
Mhm.
it's agent like a doctor, right? Uh, so it's not deterministic because the patient might eat something different every meal, right?
Ah,
Workouts, get
okay.
stressed. So it's very changing over time. So it's just you need to adjust the dosing based on the current
And you can't code for every single situation or scenario.
because you cannot limit all situations, right? Like I could eat
Ah, fair.
chocolate, but different amount of chocolates. How could you actually code that, right?
Exactly. Okay. So that's where a deterministic model fails because
Mhm.
you can't determine all the possibilities where artificial intelligence allows for that learning on the spot.
Yes. Yes.
Okay. That's really interesting. You mentioned your students.
Hmm.
How are they helping in this research?
They're helping, like they're doing they're doing incredible work, and I'm so proud of them. Two of them just came back from San Diego yesterday after presenting our work there.
You mean they had
It's,
to go to San Diego, the
I
nice
know,
weather in San
I
Diego where
know,
we're
right?
having freezing?
For them,
Oh.
right? Yeah. So they are my master's students, but I also use, or ugh, I feel like this is a bad word to use. I train undergraduate students also to do research. It's hard. It's undergraduates don't have enough time to explore and to, just focus on one thing. They want to do everything. So it's hard to find motivated undergraduate students. But they help. They read papers. They present papers to me. We brainstorm together. They come up with ideas. They come up with research questions. They implement their ideas. They try to convince me. So it's like I am the reviewer and they give me ideas. Or the other way too. I have ideas. I have research questions. They go explore. So I call them my collaborators, but when it comes to implementation, the code side of things, that's what actually they do. They excel. Um, they generate results. They plot graphs, and then we also work together in the writing part of things, like writing research papers and posters.
You've talked a lot about the simulations you've done with the gold mining,
Mhm.
and you gave us some examples with self-driving cars. Are there other examples or scenarios that you are looking forward to in the future of applying this kind of research to?
Uh, there's another application, search and rescue missions too. So it's
Yes.
like disaster response. There are a lot of applications down there. It's usually when it comes to reinforcement learning, it's usually used for drones and for defense technologies. So I'm trying to avoid that and focus on
Hmm.
the good side of things.
Now with the growing I guess vision or emphasis or however you want to word it for like world models is that something that you've considered for how that can impact your projects even just from a training aspect?
Yeah, probably that's something when we move our algorithms to the drones, we will have to use that. So I work with Dr. Paul Pauka and Miles Silman from
Hmm.
biology, Pauka from computer science, um, for the on the gold mining research, and we do multimodalities AI there. So using text, social media posts, images, remote sensing images, videos, all of that in order to predict where the gold mining activities will be next, right? Uh, so that's that. Probably when we fly the drones there, we will utilize this model inside the drone as part
Hmm.
of the reasoning component of where to go next. So the drone will take pictures and decide there are signs there, but also we could make it more predictive. Like, oh, I think the gold price is going higher today, so maybe there will be
Oh,
is there, right? So yeah, so I think, and that's Dr. Pauka's vision, is to incorporate all of these things, like the gold price, political situation in Peru, social media posts, people saying, well, even if they just took a picture of anything and part of it was like gold mining activities there. So he wants to incorporate all of these in one single model to make the decision or to predict what's going to happen next.
I love that. I love using all that available data in the massive amount of, we talk about big data that
Yeah. Mhm.
humans just can't process and can't make a lot of those connections, but that's the
Right.
strength of these algorithms.
That's true. I think I have, if you want to talk about explainability, but I
Yes.
don't know
Yeah.
how would you approach it? Like, I don't know, from the perspective of end users, from humans, like using the technology, I think they need to be empowered and to understand. Um, if you're driving a self-driving car, would you like to know what might happen if your car was driving in a road that has kids playing soccer?
Yeah,
Okay.
it's a fantastic question about why these models, make the choices they do.
Yes.
It's my favorite word that I can't say, but the mechanistic interpretability. I will never say that correctly.
I thought it's just like me. Even native speakers can add. Okay.
But I mean, Anthropic famously has teams of people trying to figure out how the products that they built themselves work.
Yes.
So
Yeah.
I guess we have brilliant Wake Forest professors and Wake Forest students doing this as
we-
well.
We're trying. So it's hard. It's a hard problem, but how we try to approach that problem is by doing it post hoc, meaning when the algorithm is trained and deployed and we have it there. So how could we try to explain? So we intentionally put the systems in difficult or weird situations and then watch how is it going to behave, right? And then translate it into a language or graphical visualization for the users to see how these algorithms behave. So, and that's part of our grant, is to build tools for users to debug systems. So if you're writing code in Java or Python or C, there are debugging tools there that you could just run the debugger, and the debugger will just find if you have a bug, if you have a problem, and it will generate test cases for you. For AI, it's almost impossible. It's infinite number of test cases, right?
Well, because
So,
as we talked about, it's probabilistic and you're not going to get the same output each time
yep.
you run it.
Right. So maybe the self-driving car algorithm is trained to avoid kids playing soccer, but how about kids playing basketball, right? What's going to happen?
Mhm.
Right?
Yeah.
So our goal is to build and develop interactive testing / debugging tools for users and developers too of these algorithms to debug their algorithms and detect these edge cases or problematic cases and fix them.
So you're doing that, as you said, on the output. Are you, for the open models, are you going in and tweaking the weights at all to find out how those work?
Yes, so that's the closed loop approach we are focusing on right now. Find these edge cases, these bugs, problems, and then take them and adjust the weights of the model to avoid making these mistakes again. Instead of retraining the model again, we just try to bring the software engineering concept from: you find a problem, a bug, you go fix the bug. You're not going to rebuild your software from scratch. So that's the same concept we want to bring to reinforcement learning. Is if we find bugs, let's fix these bugs. Let's just tell the model to avoid these problems by adjusting and fine-tuning the weights without retraining from scratch.
And so you and the students are going to figure all this out and then explain it to the rest of us in real simple terms we can understand. Is that correct?
I hope
We're
so.
counting on you.
I can't promise, but I hope so. We have 5 years to do that.
Because I really want to know, when I go ask Gemini or ChatGPT a question, why is it not giving me the answer I want?
Yeah, but you see, I think starting last summer or so, they started, if you ask, they started to show you the thinking process of the
Yes.
model. Yeah, so that's part of trying to explain.
I'm always curious if that's correct or they're just spitting out random things to make the user happy.
Well, you would need to ask LLM person.
Oh, believe me, I've had conversations with the models, and it's if you saw my chat history, you'd probably be amused. We are not always friends at sometimes. All right. Well, this has been a very enlightening conversation. I think my artificial intelligence IQ has been raised at least 10 points by your work and what you've explained here.
Oh, I'm
Really,
glad I
really
didn't
appreciate
get back to negatives.
That was fascinating.
Yeah. I think all our listeners are going to be a little AI smarter now. So
For sure.
thank you very much. Thank you for joining us.
Thank you for having me. Thank you.
All right. And I guess we'll have to pay attention to Inside WFU to learn more about your great work every time it's highlighted out there.
Thank you.
Thanks again to our guest, and thanks for listening to the Deeks.ai podcast. Please continue to follow the AI discussion by subscribing on Spotify, Apple Podcasts, and YouTube. If you have any comments, questions, or would like to join the discussion, please email us at deeks.ai@wfu.edu.